8.3 Common factors. As well as being able to remove brackets by expanding expressions, it is also important to be able to write expressions so that they include brackets. And this is called factoring or factorization. Example 1. We want to factorize 4x plus 6. So if we rewrite this as different multiples of 4x and 6, then we should be able to find what we can group or what we can factor out of the equation. So I'm going to rewrite 4x as 2 times 2 times x. Try to make it a fancy x to make it a little bit different than the multiplied sign. And then plus 6 I'm going to rewrite as 2 times 3. Okay, so these are the factors for 4, 2 times 2. These are the factors for 6, 2 times 3. So let's look at this. Let's look at this term here. And we have 2, 2x. The second term here has 2 and 3. Okay, so what terms do they each share, if any? And that would be 2. Okay, this term here has a 2, and this term here has a 2. Okay, so we can group that, or we can factor it out. So we can take out the 2. And then we can multiply it by whatever we have left. So what do we have left in the first term? Out of 4x, we have left 2 fancy x. And what do we have left in the second term? 6. Well, we have 3. Okay, so we're basically doing the opposite of expanding. We're going the other way. And if we want to check this, well, we could expand. Okay, we could expand this to confirm that we got the right thing. So 2 times 2x is 4x, 2 times 3 is 6. So you can see that is what we started with. Okay, so we're doing the opposite of expansion. We're factoring. Example 2, let's factorize 18n plus 24. Okay, so these are bigger numbers, so we're going to have a bunch more written out here. Alright, so 18. Can we divide 18 by 2? We can indeed, so we'll have 2 times. That leaves us with 9. We can divide 9 by 3, and that leaves us with 3. And of course we can't forget the n. That's the first term. 2 times 3 times 3 times n, right? That is 18n. Now, 24, can we divide that by 2? Yes. That gives us 12. Can we divide that by 2? Yes. That gives us 6. Divide that by 2? Yes. That leaves us with 3. So 2 times 2 times 2 times 3 is 24. Okay, and 2 times 3 times 3 is 18. Alright, so what's common between these two terms? Here's one term, here's the second term. What's common? We have a 2 here and a 2 here. Okay, so we can factor that out. We have a 3 here and a 3 here. We can factor that out. And that's it. Okay, so we can factor out 2 and 3 from each of these. 2 times 3 is 6. Okay, so we can factor out 6. What's left in our first term of 18n? Well, we have 3n. What's left in our second term of 24? Well, it's 2 times 2, so that's 4. Okay, if we wanted to check this, 6 times 3n is 18n. 6 times 4 is 24. So we have indeed factored that equation. Example 3, factorize 4x squared plus 6x. Okay, so now we have variables in both equations. Alright, so we're going to do the same thing. Let's write this out. So 4x squared, that can be written as 2 times x times x. Right? X times x is x squared. Now 6x can be written as 2 times 3 times x. So again, we're going to look at what is common between each of these terms. Alright, so there's a 2 in both of them, and they also both share an x. Okay, so 2 times x is 2x. So we can factor out 2x from each of these. And what are we left with in the first term? Well, 2x is left. And what are we left with in the second term? We're left with 3. So 2x times bracket 2x plus 3, close bracket, is the factored version of 4x squared plus 6x. That is to say, we have factored it. Example 4, let's factorize 5x plus 20x squared. Okay, 5x, we can't actually do anything. We have 5 times x. Alright, 20x squared. Can we divide 20 by 2? Yes. That leaves us with 10. Divide 10 by 2? Yes. That leaves us with 5. And we have x squared, so that's times x times x. Alright, so let's look at anything that's similar. We have a 5 here and a 5 here. We have an x here and also an x here. Alright, so we can factor out 5x. Now, 5x times what? What are we left with here? 1. 5x times 1 gives us 5x. Okay? We could have written in here times 1 if we wanted to. Of course, we leave that out because most of the time it doesn't mean anything or it's pointless. But of course, we could multiply times 1 and get the same answer. So 5x times 1 gives us 5x. And we are left with 2 times x in the second term, so that's 4x in the second term. And we can leave it like that, or by convention, usually we would have the higher power out in front. So usually you would write it as 5x times 4x plus 1. But for year 8, that's perfectly fine as it is. Example 5, let's factorize this guy. Now we have different variables. 3xy squared plus 12x squared y. Okay, so this is 3 times x times y again. And the second term is 2 times 3 times x times y. Okay, so quite a few things. Now we need to see what's common between both terms. Alright, this one has a 3, this one has a 3. This one has an x, this one has an x. This one has a y, this one also has a y. Okay, and that's what's shared, that's what's in common between both terms. So we can take out 3 times x times y. We can factor out 3xy from both of these terms. And we're left with y in the first term, and we're left with 2 times x in the second term, so we're left with 4x in the second term. If we wanted to expand this out to check that we got the original that we started with to confirm that our answer is correct, you can also do that.